All right, so as I said, my name is Mei Ong. I work with Gusto. Gusto is a people platform. We provide payroll, benefits, and HR solutions in a single platform for thousands of businesses in the States. I've been here actually for 6 months. I got an email just today. So I work on the product infrastructure backend team, and some of us are here actually today, so thanks for coming out, team. So my team built the background job system and do other work like ensuring the health of the CI pipeline and upgrading Ruby and Rails. I really enjoy the work, so if you're interested, come out and talk to me. So with that being said, I like to assert that we should all strive to be on the latest Ruby versions. And why is that? Ruby keeps improving thanks to the Ruby core team, but we also get stuff like bug fixes, security patches, and performance improvements, and obviously new Ruby features on the major and minor releases. So I think it's to our advantage to be on the latest Ruby version. This is a list of the current stable releases of Ruby. So we have Ruby 3.2.2 from the 3.2 series, 3.1.4, 3.06, and 2.7.8. But if you've been following along, you would know that Ruby 2.7.8 has reached its end of life as of this year, March 31st. So version 2.7.8 will be the last release of the Ruby 2.7 series. Next year, Ruby 3.0 will reach its end of life and be no longer supported. So every single year, a team or a person would have to go do the work and upgrade Ruby for your Rails application to make sure you're off a deprecated version of Ruby, or at least on one of the supported Ruby versions. So let me share with you how we upgraded Gusto from Ruby 2.7 to 3.1, or one of the blockers that we encountered. So Gusto's main real monolith ran on Ruby 2.7.6 last year, and we know Ruby 2.7 will reach end of life in March this year, so we worked on a project to upgrade Ruby. So as Nan points out here, together it took us 3 to 4 including me because I joined a bit later, about 4 months to upgrade Ruby from 2.7 to 3.1. We upgraded 2 of our largest Rails application at Gusto. So let me share with you one of the blockers we ran into for this project. So we were seeing database timeouts in various tests on our PR to introduce Ruby 3.1. The database timeouts were caused by a hang from within the active record connection pool. And so we dug into this issue and eventually found a minimum reproducible example of the problem. So when performing database queries from inside an enumerator, such as through a transaction, the program would hang and it would cause the test to time out in CI. So in order to fix this issue, we needed to understand it better. Why was this behavior only apparent in 3.1.2 and not in Ruby 2.7, which we were currently running? So the first thing we did was to track down the Ruby version that exhibits the behavior. So in this case, we would also have to run Ruby 3.0 and the various patch versions like 3.0.0, 3.0.1, and 3.0.2. So we were able to determine the exact Ruby version. So the deadlock doesn't occur in Ruby versions prior to and including 3.0.1, while in Ruby versions above 3.0.1, the deadlock occurs. So the next step is to track down the commit that caused the issue. We know that the change was introduced between 3.0.1 and 3.0.2, so we went through the list of commits. And because we also know parts of enumerator, which was one of the reasons where the deadlock occurs, enumerator is implemented using Fiber and Ruby. We saw this really suspicious looking commit in the list of backports into the 3.0.1 version. And we can trace it back to this issue on Ruby that was made 2 years ago, or around 2 years ago. And so we figured out the reason for the deadlock. And as Nan points out here in this tweet, Ruby monitors use Fiber as of 3.0.2, and since Active Record uses it to gate queries, it can deadlock if you put it in database queries inside an enumerator inside a DB transaction. So figuring out the issue was great because we're making progress towards actually fixing it. And again, this was in November 4th last year. So we worked together with Jean Boussier from Shopify and realized that there was already an issue open for this problem on Rails. And so we shared our experience with the bug, and this opened up more discussion with other people and other folks chiming in. So John and I paired on a solution for this problem, and then we have an approved PR. And so our team at Gusto, we were able to backport the changes into our own Rails application. And thanks to Nan, this entire issue is very well documented. On December 1st, we backported it successfully into our Rails application. So it took us some splunking in total into Rails and Ruby source code, and also collaboration within Gusto and also outside of Gusto. But we did eventually get unblocked, and we were able to upgrade from 2.7 to 3.1. And it took us around 1 month when we first found the root cause. So what if we were just running the latest version of Ruby and saw the deadlock when it was introduced? So this could kind of all be avoided. And this is kind of what I'm trying to sell you on in this talk. We're going to be talking about how we would run Ruby head and also why we should all do it. So what is Ruby head exactly? So Ruby head is the development version of Ruby. In Git, head refers to the currently checked out branch's latest commit, which is what we're referring to here, the head of Ruby on github.com/ruby/Ruby. It's also known as Ruby trunk or Ruby edge. It contains changes that are not yet available on a stable version of Ruby, which is why instead of running it on production, we're going to run it on our application tests and CI. That means there are 2 parallel CI pipelines for your Rails application, one for production Ruby and one for just Ruby head. This would allow us to upgrade Ruby gradually. So it won't impact your application production, but will allow you to see what tests are failing with Ruby head running. And you can make changes gradually into your main branch and see the changes pop up in your Ruby head pipeline. So once a new version of Ruby is released, it's just a matter of updating the Ruby version file. So let's talk about upgrading Ruby gradually versus all at once. So gradually means looking at issues with your build as problems arise. So it's kind of like over time versus upgrading Ruby all at once in a concentrated effort of potentially multiple engineers in a project. So the net sum of work can be seen as the same, but we don't pay. All right, what was I saying? But yeah, some of the work can be seen as the same because we all do the work to upgrade Ruby. But in fact, I'll argue it is more efficient to upgrade Ruby gradually. And let's talk about the benefits of gradual Ruby upgrades. So the first one is we would spend less time debugging. So whenever there's a failure that you see on the Ruby head pipeline, it will give you a smaller surface area to determine what the issue is. So instead of going through the commits of 2 Ruby versions, you can just see what changed within the past couple days. The next thing is it essentially gives you a free list of non-urgent to-dos. So stuff like upgrading gems that will be incompatible in the newest version, or upgrading to new language features, such as the keyword argument changes in 3.0, if you're familiar with that, and various method deprecations or removal. So it kind of gives you a list to work on whenever you have time over the year. So the next reason is to prevent usages of deprecated or removed methods. So if there is a deprecated or removed methods in Ruby, you're able to A, remove the current usages, and B, also prevent engineers from using it further and stop the bleeding as soon as possible. The next one is reduce the risk of any major upgrade issues. So in my example that I give, I think it was a rather, well, not a major upgrade issue, but it was something we didn't foresee. So if you have visibility into the changes made to Ruby in real time, we would reduce any risk of that being a blocker to your project and upgrading Ruby. And for those of you who are not Shopify and GitHub, and are under a resource constraint, I think it's a better investment from a business perspective. So once you have the CI pipeline set up for Ruby Head, you can maintain it throughout the year and be confident in the Ruby upgrade for production once the new version is released. And because upgrading Ruby will be more of a maintenance work, you wouldn't have to constantly get buy-in from leadership to run a project every single year or whenever a Ruby version is being deprecated. And finally, it places less burden on a team or a person. So gradual Ruby upgrades can be seen as more maintenance work over the years, and the effort can be distributed over time and engineers. So people can even take on issues and learn from doing this work. And it places less burden and pressure on a team to do that. All right, let's talk about some disadvantages of gradual Ruby upgrades. The first one is obviously it costs us some upfront work and resources to set up the CI pipeline or the system to run Ruby Head. The next one is it's an increase in maintenance effort. So aside from the actual Ruby upgrade work, someone has to maintain and understand the pipeline that runs Ruby Head. And lastly, because it is an additional pipeline on CI, it would cost extra. So personally, I never remember specific technical details whenever I come to conferences, but I do remember concepts and ideas. So if there's something I want you to get out of this talk is I want you to feel comfortable with the idea of running Ruby Head with your Rails applications tests. And it doesn't have to be Ruby Head either. It can be the next Ruby version that for whatever Ruby version you're running. So a quick outline of what I'm going to be talking about. We're going to build Ruby Head both locally and on a Docker image. And we're going to run a CI. We're going to create a CI schedule for the Ruby Head image. And then we're going to run a toy Rails application test on the Ruby Head image. So a quick disclaimer, there are many ways to build Ruby Head, and this is just one of it. I chatted with some other people from other companies, including Gusto, and we do it a little differently. So you should think about how it would fit into your own Rails application and CI system. So building Ruby Head locally. The first thing we can do is build it from source. So there are 3 steps. We have to generate the configuration script, compile Ruby, and then install Ruby. Let's quickly talk about the difference between compiling and installing Ruby because it wasn't super clear to me before. So compiling Ruby is converting Ruby source code into machine-readable code by a computer. So this means configuring build setting, compiling the source code, and generating the necessary binaries and libraries for your specific computer's processor. On the other hand, installing Ruby involves placing the compiled code into the appropriate directories on your local machine so that it can be used by your applications and scripts. So if you go on the RubyLang website, under the installation page and go to building from source, Ruby suggests 3 commands to build Ruby: configure, make, and sudo make install. So let's quickly talk about what each of these commands do. So configure is a command used to generate a configuration script or a makefile for the Ruby build. This is where you would specify any build options to be turned on or off. So for example, like enabling jemalloc or compiling with yjet. So the second command, make, compiles the Ruby source code into binary executables and libraries, and this is the compile step. And then lastly, we have sudo make install, which takes the compiled Ruby binaries and install it into the system. And the sudo command is used to run the installation with privileges because the default path is user local, which isn't user writable by default. So going back to this, to the RubyLang website, it actually says using the third-party tools or package managers might be a better idea. So let's just listen to the RubyLang website and set up Ruby locally using installer and manager tools. So thankfully, the Ruby ecosystem is rich and we have a lot of options. These are just 3 of the more popular ones. We have RBEnv and Ruby build, TrueRuby and Ruby install, and RVM, which is Ruby version manager. And that kind of sounds like RBEnv, but RVM is different from RBEnv. So we're actually going to talk about RBEnv and Ruby build. So RBEnv is a version manager for Ruby, and Ruby build is the plugin that RBEnv uses to compile and install Ruby. So just really quickly, we're going to use Ruby build to install Ruby head. So the command you see up there, Ruby build 3.3.0-dev, that is just Ruby head, and we're installing it to desktop. So we're going to be using Ruby build directly to build our Ruby head later on in our Docker image for a couple of reasons. So Ruby build is lightweight and configurable, and we don't need to manage various versions in our container, so we don't need to use RBenv. And finally, we just want to compile and install Ruby with some configurations. So this is a great tool to use. So before we move forward, I just want to quickly share with you how Ruby build works. So Ruby build uses something called a build definition file, and that is kind of like a DSL for Ruby build. So each method call here maps to a function in the Ruby build script that compiles and installs Ruby in a certain way. So for example, install package here installs the linked tarball. It also does the work to make sure that the correct version of OpenSSL is installed because it's kind of finicky. And then here, people relate. And then the next one is install Git. And in this case, instead of installing from a link, we're installing Ruby master from GitHub. And then there's various options there, but I want to point out two options here. The first one is standard install with bundled gems. So this is not to be confused with bundler. Bundled gems are similar to normal gems, but are automatically installed when you install Ruby. And because we're installing from Ruby source code in GitHub, we need to install it with the bundled gem. And then the second one I want to point out is verify OpenSSL. So this does the work of verifying that key libraries and headers exist on our computer so that when we compile Ruby, it has all it needs to compile properly. With that being said, Ruby installers obviously does a bunch of stuff for us, which is why it is more convenient to use them instead of doing everything manually. So for example, it downloads dependencies, both system and Ruby dependencies for us. We download the Ruby source code, we verify and extract the Ruby, and download and apply patches. So this is important if you want to patch your Ruby language with something that is not already in an existing version. And then finally, we compile and install Ruby. So it is also worth noting there are other ways to set up your local Ruby environment, including using a package manager like Homebrew on Mac OS. But these methods typically involve installing a pre-compiled binary rather than compiling from source, which is much faster, but only has the latest patch version. All right, now let's get to building Ruby head on Docker. So Docker was a really fun tool for me to learn. I've never used it before prior to this, but it allows you to package and run applications in a consistent and portable way. So we'll be creating a Docker image which has Ruby head on it, and essentially we can run our application using that image. So we do already have Docker images for Ruby that is maintained by the Docker community. They support various versions of Ruby based on your OS preferences, but the Docker official images do not support Ubuntu-based Ruby images, which is what we use at Gusto. In fact, there's a PR open, or there was a PR open on the Docker library to introduce Ubuntu-based Ruby, but the maintainer essentially said they only support more lightweight OS. But that's okay, because we're free to build our own. So let's build our own Ruby head on Docker. All right, so this is a Docker file for Ruby head. I'm going to step through each of it so that we see what we're doing in this image. Docker image. So the first thing we want to do is specify the parent image to build from. So in this case, we know that our OS is Ubuntu, so we want to build from a Ubuntu image, version 20.04. The next thing we want to do is copy the build definition file into the Docker image. So that is what we're going to be using to build Ruby head. And then we want to set up gem and bundler paths and environment because, as we know, this is a clean image. We don't have the defaults that we would have locally. So we have to set it up ourselves. Next, we want to install system dependencies and then install Ruby dependencies. And then finally, we want to compile and install Ruby. So let's zoom in into this section. So the first thing we're doing here is download Ruby build from GitHub. And then we want to extract that tarball and then manually install it. And this is where we're actually using Ruby build to build Ruby head. So instead of specifying 3.3.0-dev like we did last time, we're going to use the build definition file that we've previously copied into this container and install it to /user/local. And then we want to remove Ruby head because we want to keep our container clean. So once we install it, we don't need it anymore. And we want to we want to create a directory for our gems if it isn't already created. So let's take a look at what the build definition file for Ruby head looks like here. So similar to the one you just saw, instead of installing from GitHub, we want to use something we call snapshot master, and it's provided by the Ruby lang. So if you go on the Ruby website on the downloads page and scroll down, you're going to see something they call nightly snapshot. So this is a tarball of whatever is in Git made nightly. It may contain bugs or other issues. Use at your own risk. So this is the link that we're going to use to install our Ruby head. So once we have the image, we can build it. And we just call docker build, and we build that image. And then we can run it. And as you see here, we are on IRB, and the Ruby version is 3.3.0, which is the next Ruby version. And the Ruby description indicates that it is a 3.3.0 dev. All right, so this is the section I was going to talk about jemalloc, but because of time constraints, I won't be going into it, but I'm happy to talk about it if we have time after. Who here is interested in jemalloc? Okay, cool. Noted. Okay, moving on. So what we want to do now with our Ruby head image is to build it and push it to Docker Hub. So Docker Hub is a container image library, like a central repository for Docker images. And it makes it easier for us to distribute and deploy our applications since you can just pull the same image and run it anywhere. So in order to do this, we're going to set up a pipeline on Buildkite to build and push the image to Docker Hub for us. So we have two commands in this pipeline. The first one is to actually just build the image like we did locally just now. And we add a tag to it to make sure that the image is tagged. And then once it is built, we push that image up to Docker Hub. And this is what it looks like on Docker Hub. You can see it uses this Ruby head build tag. And we also have another image for jemalloc, but I wasn't going to talk about that. So, all right, so now we have a pipeline that runs. So whenever you run this pipeline, it builds a new Ruby head version and pushes it up to Docker Hub. But now we need to keep our Ruby head Docker image up to date nightly because, as I said before, Ruby head is constantly moving and updated every day. So let's set up nightly builds on Buildkite. So Buildkite has this thing called scheduled builds, and that's what we're going to use. So let's go to pipeline settings, create a new schedule, and here we just set the cron interval to run every day at midnight UTC time. So we would have this pipeline run every day at midnight UTC. Okay, so now we have a Docker image with Ruby head on Docker Hub. Let's use that Ruby image with our Rails application. So I created a really simple Rails application and wrote a Docker file for it. So what we're doing here is specifying the parent image, which is the Ruby head build that we just created, specify the working directory, and then we're going to copy a gem file specifically for Ruby head into our Docker image and run bundle on it to set up our gems. And then finally, just copy over the relevant Rails application files that we need. So on Buildkite, we have a pipeline for our Rails application. So here, we're going to build the Docker file the Docker image that we just created for our Rails application. We're going to wait for this step to complete because we need it to finish building before we can use it using the Buildkite Docker plugin. So the Buildkite Docker plugin essentially just runs the image in a container with the following command, and we're going to run it with ruby-v, which prints out the Ruby version, and then rig test, which runs our application tests. And then we're going to see this very green build. So we're not going to usually see a green build if you've done it before. You're definitely going to encounter some failures one way or another. But in this case, because it's simple, it's green, and if we look into it, you can see that it is indeed using 3.3.0 dev, which is RubyHead. All right, so that was kind of a lot. So let's quickly recap. So we have RubyHead running on a Docker Hub, which we have a pipeline updating that image every single day. And then on the other hand, we have our Rails pipeline that pulls from that RubyHead image and runs our applications tests on it. So let's just quickly talk about some caveats of gradual Ruby upgrades. So one thing I wanted to point out to you is that for this to work, your application tests and CI pipeline have to be robust and reliable. Like you have to trust in your applications tests and CI pipeline in order to do this. Otherwise, running a pipeline with a different version of Ruby might be a little counterproductive. If you want to talk more about that, I'll be happy to talk to you about what our CI mentality is like. So going back to the benefits of gradual Ruby upgrades, I wanted to point out 2 extra benefits. That is, if you have a pipeline and you're managing this pipeline, I think it will help you stay updated with the latest features of Ruby. And Ruby is constantly changing and improving, so it is cool to keep up to date with what the changes are. Secondly, if you find any edge cases in your application, you can create an issue upstream and discuss it there. And it gives us a great way to contribute to the Ruby language and community. Yeah, so Ruby is constantly changing, and let's help it evolve to the way that we use it. So I want to encourage you to be an active participant in the growth of Ruby and also Rails if you find anything, if you encounter any issue with Rails. And we can do it through this feedback loop. So if you're a Gen Z, you'll be saying, that's dope, Maple, but what can we do today? So I'm part of this group called WNB.RB. It is Women Non-Binary Ruby group. And we have this website that is a Rails application. And I sometimes contribute to this Rails application. It is also open source. And so when I was writing this talk, I was like, hey, what is a great way to for people to take away from this talk? So if you maintain or run a Rails or Ruby library that is on GitHub and open sourced, I would really encourage you to run RubyHead with GitHub Actions. It is actually quite easy if you use the setup Ruby GitHub Actions. You just kind of add head to the Ruby version matrix, and you will have it running on CI. So I think that's really cool. So try that out and see how your CI runs. Thank you so much. I hope you enjoyed the talk and learned something. Yeah. I actually do have some time, so I'm going to talk about jemalloc for those of you who raised your hand. So jemalloc. All right. So as you know, large-scale Rails application can be memory intensive, especially if it's multi-threaded. So for example, if your Rails application uses Sidekick or Puma, it is multi-threaded. And also Ruby is a dynamic language, which means it is flexible and adaptable at runtime. And objects can be created dynamically, which allows for dynamic programming and all the things that we love about Ruby. So it does take up memory resources. So this is where jemalloc comes in. Jemalloc is a memory allocation library. It is an alternative implementation for malloc, which is a memory allocator used by the OS to allocate memory for running programs. So jemalloc implements a more efficient memory algorithm that specializes in reducing fragmentation. So fragmentation occurs when a memory is allocated and deallocated in a way that leaves behind small gaps or holes. And the gaps or holes in memory can add up over time and lead to memory inefficiencies or maybe even worse, memory allocation failures. So jemalloc uses something called per thread caching, which records cache of memory blocks that were previously allocated by a thread. And so when a new thread needs to allocate memory, it first checks its own cache to see if there's a memory block of the same size that can be reused. So this saves performance overhead into calling to the main allocator, and overall resulting in better performance. And the caveat here is better performance in programs that require memory allocation and deallocation. And as I said, multi-threaded applications. So I just wanted to mention that we should recognize that jemalloc is not a drop-in replacement memory allocator, and it's not a silver bullet, which is one of the reasons why Ruby does not ship with it by default. So use it with caution. So there are two ways that we can use jemalloc with our Ruby. The first one is through a compilation flag. So remember the configure command that I mentioned before? If you specify it with --jemalloc, with jemalloc, we will tell the Ruby to build with the memory management functions linked against jemalloc, and Ruby would use it as a default memory allocator instead of whatever the operating system's default is. So please note that also, if you do this, some native libraries that are compiled against other types of memory allocators won't be using jemalloc, just Ruby. So that's one way. The second way is to preload the jemalloc library before running Ruby. So we do this by using an environment variable called ld preload. And ld preload is an environment variable that is used to override functions or symbols in other shared libraries to provide alternative implementations of these functions. So essentially what we're doing is we specify, hey, use jemalloc instead of whatever memory allocator you're going to use. So we do this by just exporting the shared library object into ld preload environment variables. So you might be wondering what the difference is and which one is better. Anecdotally, from reading about this online, preloading jemalloc seems to reap the most benefits in terms of memory compared to just compiling Ruby with jemalloc. And thinking about why that is, it kind of makes sense because if you compile it with the compilation flag, it would only impact Ruby. And on the other hand, if you use ld preload to preload jemalloc, it would impact all native libraries and not just Ruby. So to get the most memory savings, you should use ld preload. But please also note that preloading jemalloc will impact child processes. So you might see potential incompatibilities between jemalloc and apps like Google Chrome. So you need to be aware of that. It's not a silver bullet. So just to be safe, or just to try things out, you can totally just compile Ruby with the jemalloc flag and see if you reap any memory or performance benefits. And that is all. Thank you.